Aceves, and I'm here to talk about chemical examination of urine. Routine chemical analysis or examination of urine is the chemical analysis of urine that involves a number of tests to detect and measure various compounds that pass through the urine. It uses the reagent strip and has two major types. It is the chem strip and the multi-states. Reagent strip method. This is a primary method for chemical analysis of urine. It is simple and rapid in performing medically significant analysis. This includes pH, protein, glucose, ketones, blood, bilirubin, urobilinogen, nitrite, glucoside, and specific gravity. Reagent strip pad. These are chemical impregnated absorbent pads where it has a color-producing chemical reaction when contacts with urine. So this is the reagent strips and its container. So in the container, it has the chart, and this is shown. This is used for comparing results. Reagent strip technique procedure. Dip the reagent strip briefly into a well-mixed uncentrifuged urine specimen at room temperature. Remove excess urine by touching the edge of the strip to the container as the strip is withdrawn. Blot the edge of the strip on a disposable absorbent pad. Wait for the specified amount of time for the reaction to occur, and compare the color reaction of the strip pads to the manufacturer's color chart in good lighting. pH. This test is primarily an aid in determining the existence of systemic acid-base disorders of metabolic or respiratory origin in the management of urinary conditions that require the urine to be maintained at a specific pH, and also in the identification of crystals and determination of unsatisfactory specimens. So, normal random samples of healthy individuals is equals to 4.5 pH to 8.0 pH, while in healthy individuals' first morning samples, the pH range is 5.0 to 6.0. However, unpreserved urine has a pH of 9.0, which is very basic. Here we have the reagent strip of pH. It has two indicators, the acid indicator, which is the methyl red, and the alkali indicator, which is the bromthymol blue. The color changes and correspond to the urine specimen's pH at the reading time of 60 seconds after dipping. Its principle is a double indicator system, which are the two acid and alkaline indicator. The red to orange results are at a pH range of 4.0 to 6.0, which is acidic, and the green to blue results are at a pH range of 6.0 to 9.0, which is basic. And here are the clinical significance. Protein. Protein is the most indicative for renal disease. Its physical indication is the presence of white foam in the urine. Albumin. Albumin is a major serum protein found in normal urine. However, higher normal values of urine indicates renal damage or disease. So these are the normal values. In Strasinger is less than 10 milligrams per deciliter or less than 100 milligrams per 24 hours. In Henry is less than 150 milligrams per 24 hours. Here we have the reagent strip of protein. Its protein indicator is tetrabromophenol, which is common. The color changes and correspond to the urine specimen amount of protein at a reading time of 60 seconds after dipping. Its principle is the protein error of indicator. The positive results are at a color range of blue to green, and the negative result is yellow. And here are the clinical significance. Glucose. Glucose is most frequently tested in urine. It has the renal threshold, where plasma concentration of a substance at which sugar reabsorption stops. Here, the blood glucose level exceeds about 160 to 180 mg per dl, to which the proximal tubule becomes overwhelmed and thus begins to excrete glucose in the urine. Here we have the reagent strip for glucose. The glucose indicator in reaction A is glucose oxidase and in reaction B is peroxidase. The color changes and correspond to the specimen's amount of glucose at the reading time of 30 seconds after dipping. Its principle in glucose oxidase is double sequential enzyme reaction and in copper reduction test is copper reduction. The positive result is green to brown and the negative result is blue. And here are the clinical significance.
Ketones. Ketones are increased fat metabolism due to compromised metabolism of carbohydrates to energy. So metabolism of body fat to energy is impaired. No measurable amounts of ketones should be seen in normal urine.
Strip for ketones. The ketone indicator is sodium nitroprusside. The color changes and correspond to the urine specimen's amount of ketone at the reading time of 40 seconds after dipping. Its principle is sodium nitroprusside reaction. The positive result is uniform purple in color, and the negative result is pink or pale pink in color. Positive and questionable results may be confirmed with acetous tablets. And here are the clinical significance.
Blood. Blood may be present in the urine either in the form of intact red blood cells or as a product of red blood cell destruction. Blood present in large quantities can be detected visually. Hematuria produces a cloudy red urine, while hemoglobinuria appears as a red clear specimen. However, myoglobinuria cannot be distinguished through visual examination. Any amount of blood greater than 5 cells per microliter of urine is considered clinically significant.
Here we have the reagent strips for blood. The blood indicator is pseudoperoxidase. The color changes and correspond to the urine specimen's number of blood per microliter at the reading time of 60 seconds after dipping. Its principle is pseudoperoxidase activity of hemoglobin. The positive result is uniform green or blue for hemoglobinuria or myoglobinuria and spotted or speckled in intact RBCs. And in the negative result is tan or nude and no spots.
Bilirubin. The appearance of bilirubin in urine can provide an early indication of liver disease. It is often detected long before the development of jaundice. So bilirubin is a highly pigmented yellow compound. It's a degradation product of hemoglobin. So the physical indication of urine is the amber color with yellow foam. Urobilinogen. It is a bile pigment that results from hemoglobin degradation. So it is when conjugated bilirubin is excreted through the bile duct into the intestine. So the normal value is less than 1 mg per dl or Elbridge unit, or 1 to 4 mg per 24 hour, or less than 1.0 Elbridge unit. So the specimen acquired is an afternoon urine because it is the peak levels. Nasa afternoon ang peak levels ang urobilinogen. So dapat nakuha.
Here we have the reagent strip for bilirubin. The bilirubin indicator is diglucuronide plus diazonium salt. The color changes and correspond to the urine specimen's amount of bilirubin at the reading time of 30 seconds after dipping. Its principle is diazo reaction. The positive result is pink to violet in color. Questionable results can be repeated using the ICTO test. Here we have the reagent strip for urobilinogen. The urobilinogen indicator is p-dimethylaminovenzaldehyde. The color changes and correspond to the urine specimen's amount of urobilinogen at the reading time of 60 seconds after dipping. Its principle is the Ehrlich reaction. The positive result is dark pink to red, and its negative result is pale pink or pastel pink. And here are the clinical significance.
Nitrite. Nitrite is a rapid screening test for UTI or urinary tract infection where there is a presence of bacteria. It is designed to detect cases that may not need culture. So, nitrite is normally present in urine. So the specimen acquired for this type of test is first morning or 4-hour urine. So the clinical significance of urine nitrite is cystitis, arthritis, antibiotic therapy, and urinary tract infection.
Here we have the reagent strip for nitrite. The nitrite indicator in reaction A is p-arsenilic acid, and in reaction B is hydroxy-tetrahydrobenzoquinolene. The color changes and correspond to the urine specimen's amount of nitrite at the reading time of 60 seconds after dipping. Its principle is Grice reaction. The positive result is uniform pink, and pink spots or edges is also considered as a negative result.
So leukocyte and esterase. The normal values for leukocyte in urine is to 0 to 2 or to 0 to 5 per high power objective field. So the clinical significance are bacterial and non-bacterial urine tract infection, screening of urine culture specimen, and inflammation of urinary tract.
Here we have the reagent strip for leukocyte esterase. The leukocyte indicator in reaction A is indoxyl or pyrrole carbonic acid ester, and in reaction B is indoxyl or pyrrole plus diazonium salt. The color changes and correspond to the urine specimen's number of leukocytes at the reading time of 120 seconds after dipping. Its principle is leukocyte esterase. The positive result is uniform purple, and the negative result is colorless.
And finally, specific gravity. So the density of solution compared with density of similar volume distilled water at a similar temperature. So influenced by number and size of particles in a solution. So the normal specific gravity in random specimen is 1.003 to 1.035. When specific gravity is less than 1.003, it's not a urine except in diabetes insipidus specimen. So when specific gravity is greater than 1.040 is due to radiographic dye.
Here we have the reagent strip for specific gravity. The specific gravity indicator is pKa polyelectrolyte. The reagent is sensitive to the number of ions in the urine. The indicators change its color in relation to the ionic concentration of the urine specimen at the reading time of 45 seconds after dipping. Its principle is pKa charge of electrolyte. The specific gravity of 1.000 turns to blue, and the SG or specific gravity of 1.030 turns to yellow. And here are the clinical significance. This will be all for the chemical examination of urine. I hope you enjoyed and learned something. Until the next performance task. Bye!